Okay, thank you very much for the introduction, and yeah, thank you all for coming to this event, because especially the cellular agriculture is a very new field. People's attention and understanding is what is the most needed. And today I'm going to talk about how open source DIY cellular agriculture, which is what we are doing in Shoji Meat project, is turning into a business which we do as a Integriculture Inc. And so this is a quick introduction to what Shoji Meat project is and what Integriculture is. And Shoji Meat project is basically the citizen science movement for cellular agriculture. And it's very interdisciplinary, multidisciplinary, and people, including non-scientists, are involved in this project. There are people working on ethical studies, and there are even manga artists drawing manga based on cellular agriculture and cultured meat. And this commercialization cluster, that's where we talk about business, and the first spin-off coming out of this Shoji Meat project is the Integriculture Inc. And this is this entire organization is kind of we call it a movement, or it could be hobbyist club, or in Japanese called Dojin Circle, or we indeed have a fanzine. We actually sell this in comic market or Comic Con. Yeah, we also did presentation in Nico Nico Chokage, which is basically an anime convention. And yeah, some of the latest developments, and this is also kind of a quick summary of what we are doing. So that's one of the volunteers selling these fanzines in comic markets in this summer, and that's artists working on speculative design on what the cultured meat unit for apartments is going to look like in the future. And that's high school students growing meat at home, and these are the cultured foie gras and cultured meat that I made in my house, and that's what we call green meat. It's a mixture, it's a algae and muscle cell co-culture. And that's how we share our finding, which we basically upload everything on Nico Nico Video so that people can just comment on spot. And so, Shoji Meat Project is self-funded, and it's entirely independent from any university or corporation, which means we can do anything we want, including stuff like that, fun stuff. Yeah. Yeah, probably making an anime is not an option if we are working under university or the corporations. Okay, and these are some of the selected members. Although there's a line here, separating between Shoji Meat Project and Integriculture, most people here are also part of Shoji Meat Project because it's entirely private. So we have students and high school students and artists, and there's me, and actually we have PhD holders as well. So we have lots of different sorts of people working in different fronts. And so what do we have to do? What are the challenges we have to face? These are mostly technological and social. So from technological aspect, it needs to be bigger and cheaper, because as some people know, the first cultured meat burger made by Professor Mark Post, it costs $350,000 or something. It's very, very expensive. That has to come down. It must be at the end, this thing has to be low cost. This thing has to use low cost technology to bring it to a level that consumers can actually buy. And also, as Erin has also talked, it needs to be understood more. Yeah, so what exactly are we doing? So to make cultured meat cheaper, it's actually, a lot of the cost comes from the culture media. And culture media, if we look at some of the components, it's basically sugar, amino acids, minerals, and those things. And we thought, can we just buy them in supermarket, or because it's in Japan on a vending machine on the streets? And we did. And we basically tested 15 different sports drinks, including world's famous Pocari Sweat or those things. And before actually sticking into the culture, but we've tested the osmolarity and the pH, and it was kind of surprising that most of the sports drinks are actually quite acidic. But osmolarity was kind of right, so we picked the one that is the closest, which is the green Dakara, and adjusted the pH, stuck that into culture medium. We mixed it with DMEM. It's a medical culture medium, and up to 60% we could just mix up to 60%, we could just mix it with like no bad side effects on the cell culture. But that's not quite enough, so we also did. Why isn't the next slide loading? Okay, there was meant to be a slide in between this and that, but it's basically, it talks about like replacing another part of the culture medium, which is called like fetal bovine serum. It's basically treated cow blood, which is very expensive, and also, as long as you use that, you're still killing cows. And also, it carries the risk of BSE, other viral infection, and those things. And we don't want to use that. So we basically decided to replace that with something else. And we decided to do that with something called yeast extract. And for yeast extract, it is something that beer companies throw out every day in huge quantity. So we basically bought a little bit of that, took it into my house, in my bathroom, and did an experiment at home. My parents are not very happy, but I still did it. And at the end, we could make an FBS substitute. And while FBS costs like, how much is the one? I know, $1,000 per liter. In the way we, if I do it by DIY in my bathroom, it costs about 10 to 5 cents per liter. So it is, in a way, a game changer. And the yeast extract is also dog food. So we're basically converting dog food into cell food. Yeah, and combine that with like sports drink. Obviously, for the immediate technological milestone, we want to make, so we got up to 60%. Obviously, we want to make it 100%. Yeah. And out of that, we came, out of all those experiments, we came up with this thing, this technology called network co-culture, and we call it the Covenant system. And what's happening here is that different types of cells are interacting each other. So probably none of you have actually like, what is it, like injected in FBS or like blood serum or the culture medium into your bloodstream. Because the reason is our body has got the capability to produce those like cell culture medium within our body, which we call like blood or body serum, those things. And what's happening here is basically simulating the mechanism that produces blood serum inside our body. So that, in a way, that's liver, that's pancreas, and there's those muscles. And by doing so, what happened was, in conventional cell culture, what happens is you got all the capex, which is all the equipment, and you need culture medium, and also you need like, all sorts of growth hormones. And if all these are added together, it becomes like very, very expensive. But by doing cell culture by this method, it becomes a lot cheaper. And if we scale it, it becomes even cheaper. And that's sort of the level where we can actually sell it to supermarket and general consumers. And that's one of the demonstrations. So because we are culturing cells, not just muscles, so we can do other cells there. So we picked on like liver cells. Then we made clean foie gras or cultured foie gras. And what we did was, using that system, we basically stimulated the cell growth of liver cells, like avian liver cells. We extracted chicken cells from fertilized egg we bought in the supermarket at 50 yen or $0.50. So it's again also a very low cost thing. So we grew the cells and also fat loaded the cells and assembled or aggregated the cell and in quantity so that we've got this cultured foie gras here. And we did a like drinking party or nomikai using this kind of cultured foie gras. So we tasted it. It had a lot of umami and sweetness, but the problem was that none of us were actually rich enough to know the real taste of foie gras. But one thing we could say is that it tasted like food, and that's, I think, it's a good enough sign. Okay, so how does this fit into the bigger context? And this is actually that wording is not very good. I should have put it like challenges to our challenges in our food system. And what in a wider context, if you look at the food problem, what's happening is that these food technologies needs to really scale to like millions of tons, or even like 10 or 100 times more than that. And when doing so, the people's interests don't necessarily align with the investors' interests. And also, as a result of that, we have this trade secrets problem going on, and as a result of that, mistrust from people, like it happened to GMOs. And also, we have this like customer segmentation, because if you look at food market, the variety is huge. And that variety is also what we call a culinary culture, and we don't want to lose that. And this is how we look at them, how we approach that thing. And that's where like Shoji Meat Project will look after, that citizen science domain. So people will try all sorts of different things. While in this region, where level of personalization is low, but the demand is huge. So that's where the money is, and that's where the like agricultural startups should go. And occasionally, probably we would start having like whatever tested here becomes a product here. So our general approach on IP is basically how to make it open, how to scale its proprietary. And that's basically straight out of the pitch deck of Integriculture Inc. So we plan to start with the cosmetics and those ingredients, and then scale into foie gras, and then further into clean meat, and then at the end, like cultured meat, like clean meat plant. And these are the technological R&D milestones. And because we start with high added value things, that basically makes the payback time a lot faster. And meanwhile, Shoji Meat projects will keep on doing some fun stuff. So these are some of the experiments that's already going on, and that's CCO culture is already done by those high school students, and they're doing it at home. And they came up with this idea. This mic came out. Okay. Yeah. So what Shoji Meat Project is trying to do is basically what used to happen is that whatever coming out of academia used to go straight into like business, but that problem is it failed miserably in terms of public perception in case of GMOs. But obviously, we know what happened, so we're not repeating that mistake. So basically, Shoji Meat Project and something like citizen science will look at this technology and actually do something, and then businesses scale like Integriculture. And how do these two, like citizen science and also the businesses, like interplay? That's basically our plan. So we did the Shoji Meat Project has done all the DIY bio stuff that's turned into a CalNet system, and that Integriculture is trying to commercialize, and that's going to scale into clean meat plant, while a home scale the CalNet system will turn into this kind of like what we call like home grade culture, meat culture vat. And what's going to happen is that people will start experimenting with this. So like local farmers. So if everything turned into so-called cultured meat by big corporations, probably we will lose like all the Kobe beef or all sorts of local brands. But because farmers and people can try different sorts of meat using this, we will probably end up with a huge variety of meat. And that will obviously like come back into like clean meat plant, and we will get a variety of meat. And this will all end up on the cloud for like a recipe. And after that, we could do that for like fish sales, like fish meat, or like that's be like scaled cultured meat plant. And we could do that in like this kind of huge farm high rise, or take that to Mars like that, or do that in zero gravity like that. Yeah, too much of Gundam and Robotech, but it's okay. Anyway, yeah, thank you for listening. So that's where we are up to.